Hello, so in this video, it's kind of a promise that I made in the last video, which is, why are these things equivalent? So you notice that there's different versions of the formulas SXY, SYY, SXY. Notice that these things are really just shortcuts, okay? They're shortcuts for formulas which you don't kind of want to remember, or maybe they're shortcuts because you notice a pattern, okay? You don't want to write it out each time, okay? So I wanted to show you why are these two things the same. So I'm only going to use it with one because I think you can do it with any of the other ones. I'm just going to show that SXX, those two things are the same. So in other words, that the sum of xi minus x bar all squared is in fact the same as the sum of doing xi all squared minus n times by the mean of x all squared. And obviously then you can follow exactly the same principle and exactly the same technique for SYY and SXY as well. Okay, so let's try and show that this is true. The way which I'm going to do that is just by focusing on the left-hand side and trying to get to the right-hand side. So otherwise, I'm just going to focus on sum of xi minus x bar all squared. Let's see what we get, okay? So first things first, I can see a sort of a quadratic that I can square out. So I can get the sum, so in other words, I'm just squaring that thing out. I can get the sum of xi squared minus 2 lots of xi times by x bar minus, plus x bar all squared, okay? And I'm just going to distribute my sum over this expression. So I get the sum of xi all squared minus, well, let's think about this, the 2 and the x bar, they're just numbers, okay? They're not changing with each sum, they're just a number, okay? They're constants if you like. It's the xi which is going to be changing because that's going to be talking about looking at different values of my independent variable in this case. So it's going to be 2 times by x bar, that's my constant, and I'm going to pull it out, times by the sum of xi, okay? Then I've still got x bar all squared. Be careful actually here, because if I'm adding on, if I'm summing x squared, well, how many times am I going to add on x squared? I'm going to do it n times, right? Because there's going to be n data points. So for all of the sums that I do for the other variables, I'm going to have n lots of x squared left over. So I'm going to have n lots of x bar squareds left over. Okay, good. Now you're probably looking here thinking, yeah, but that looks nothing like that. That looks nothing like that at the time being. But just watch. The magic happens when I remember what x bar is equal to. Because x bar is just simply the sum of each independent variable divided by the number of independent variables I've got. So the sum of x divided by n. Okay, so add them all together, divide them by n. So if I replace x bar with this, then what do I get? Well, I haven't changed the first term because there's no x bar there, so I keep that the same. But have a look at the next term. I get 2. Well, x bar now is equal to the sum of xi divided by n, and I'm timesing all of that by sum of xi. Okay? And then I have on the end here n times by x bar squared. So x bar, remember, is just sum of xi over n, and I'm squaring that. So okay, let's just kind of consider what we've got here. So at the moment I've got the sum of xi all squared, sum of xi squared. Have a look here. I have minus 2 of, we'll have a look. Let's think about this. If I have sum of xi times by sum of xi, that's a bit like saying y times by y. In other words, I get y squared, right? It's just a variable, so sum of xi, and I'm squaring all of that. And then I'm dividing all of that by n. Okay. Now notice that that thing and that thing is different. Because the first thing, okay, so sum of xi squared is literally saying square all your data values first, then sum them. Whereas when I'm talking about this, the sum of xi all squared, I'm saying add all your data values together first, then square it. So the order is different, okay, so they're not the same, right? So okay, and then on the last thing, well, if I have a fraction which I square, I just square the top and square the bottom. So I get the sum of xi all squared, okay, so square the top, over n squared on the bottom. Now hopefully you can see that n and that square will cancel in there. So in other words, what I'm going to be left with is the sum of xi squared minus 2 times by the sum of xi all squared divided by n, plus, have a look on the end here, I've got the sum of xi all squared again divided by n, because there's only one n because the n squared and the n is cancelled there. So have a think, okay? If I have 2 lots of something, maybe if I write the 2 slightly bigger, you might be able to see this a little bit more. Have a look. I've got something here, and I've got the same thing here. So if I have take away 2 lots of something and add on 1 lot of something later, then how much of that something am I left with? -1, right? So this is equal to the sum of xi squared minus xi all squared divided by n, okay? Now, if you think about this, I can make this thing look a bit more like a mean, because remember, I'm trying to make it look exactly the same as this thing here. So I can make this thing look a bit more like a mean, because I notice that I've got sum of xi over n, almost. Okay, I've got sum of xi over n, almost, right? So all I need to do is convert this back into a square fraction. Okay, so in other words, I get the sum of xi squared, don't change that, minus, well, this is the same as sum of xi all squared divided by n squared, okay, and times that by n. Okay, so literally just going back where I came from, kind of, right? So just times that by n, because of course those will cancel. But have a look then, because of course I'm squaring numerator and denominator, so therefore this is the same as the sum of xi squared minus n, lots of the sum of xi over n, all squared, right? So I'm going backwards now. And of course, what's that thing equal to? That's right, it's just x bar, okay? So I get sum of xi squared minus n times by x bar. Hence, the thing which I started with, which was this thing all the way up here, okay, this thing all the way up here, is in fact equal to the alternative formula which you will sometimes see written in the books, okay? So notice there's 2 versions of this formula. So this is SXX. 2 versions of the formula, either this thing or this thing. It doesn't matter which you use, okay? But as long as you see, they are pretty much exactly the same thing.